Hello everyone and welcome to the X3M TIG channel. So for today's video guys, I'm going to show you the work I did on a temperature valve in a power plant. This beast sprays precise cooling water into superheated steam lines. It controls temperature and protects turbines from overheating during startups, shutdowns or load exchange. One side is a 14-inch SCAD 100 and it's a P22 material. It's great for heat steam with solid creep resistance up to 1000 Fahrenheit. And the other side is a 10-inch SCAD 120 P91 material. Usually they choose that like for superior strength and oxidation resistance, other extreme pressure and temps on the feed water spray side. Okay, we're kicking off with the valve wide open. You can see here this 14-inch and there is some residual water inside from machining. So we gotta clean it before purging or anything. So I'm gonna use a ragged dry, maybe preheat with a TIG torch. Preheating is good with a TIG torch. It's a little bit faster, but still you have to use rags and clean it. Maybe use the acetone as well, so you don't have any oil inside. As I said, machine prep bevels. Make sure that they're clean. I always like to go inside at least 2 inches, from the edge, in and out. We put a plug here from machining to prevent all that debris from machining to go deeper inside the pipe. You're just gonna use some rags, clean it. This is the best and easiest way. Once everything is done, clean and dry, the QC gotta do inspection before we start doing purge. And for the purge, this is first time I'm using. This is like a purge film. I never used that before. Usually I'm using rice paper, but this is like from Arc Weld company, water soluble purge film. It's pretty cool, so I'm gonna cut 3 pieces to match that 14-inch pipe. It's pretty cool. Looks really thin, transparent. As I said, we're going to use 3 just in case. We're going to make like a 3 chambers just in case one fails, so we got 2 more. We got to push it as far as we can because all that preheat and chiclets outside the pipe. And the same thing with we're going to use that water soluble adhesive or glue. Just use a paintbrush and just use it inside the pipe where you're going to install that dam. It's a little bit picky, kind of sticks to your fingers, and it's really thin. So this is the one is done, so we got to put 2 more. As I said, like 3 chambers. That's the idea, just in case one fails, so you got 2 more to protect your purge. Same thing on the bottom one as well. Deep inside as much as you can. We gotta just take a photo just in case, so we know it's here, it's installed. Because we're working in the 2 shifts, day and night. There's a lot to work here. Now we got a preheat process before any tacking. Everything gotta be up to temperature. 4 solid tacks. This is P91 material. I'm just gonna use bridge tacks here. The gap is pretty good, 532. And vertical side, same thing, 4 good solid tacks. This is for P22 material, 14-inch. This is SCAD 100. It's a little bit tight on the bottom. This is 332, is gonna perfect for that. I recommend 332 on stuff like this. There's a couple benefits: easier to melt, faster to finish. One ain't on the top. We're using 16 pack. We don't have any header, so we're just gonna put individually all the flow meters here, all the gauges. I'm gonna use 2 purge lines per joint. I'm just gonna start 1 joint at a time because they're gonna do X-rays on after hot pass. They call it info shots, just in case something's failed, so they don't want to continue on. That's why they want to make sure after X-ray is good, so they can continue on welding. So I gotta finish horizontal and vertical weld, then they're gonna do info shots. Okay, and before we continue on, just gonna do a little promo video about my TIG sleeve, so you can check it out. Let me introduce you to TIG sleeve. This is TIG rod storage tube, a special design for TIG welders. Every unit is handcrafted, features an O-ring seal to protect your TIG rods from moisture, dust, and any damage. 37 inches in length, so it's gonna fit full-size TIG rods, weighing just 2.6 pounds with a 10-pound rod capacity. Strap it over your back to stay mobile and hands-free while you're climbing, crawling. Comes in 5 different colors, and you can check it out on tigsleeve.com. For my filler wire, it's ER90S B9. This is for P91 material, and B3 is for P22. Okay, I'm starting on a vertical side. As I said, 332 filler wire, 110 amps for this one, cup size 8, tungsten 1/8. I'm using the lanthanated tungsten. No cold stabs inside. One of the benefits with 332, easier to melt, and a little bit faster to finish the root on a pipe, especially on a higher diameter pipes. Smaller gap, as long as you stay right in a puddle, everything should be good. I'm kind of backfeeding a little bit. Just keep the rod slightly inside the bevel, inside that edge. Okay, and the quarter is done. I got to get rid of that bridge tack here and finish the pipe. I can't do any root videos as it's really too hot, so I'm just scared not to damage any of my recording equipment. So now I'm gonna switch to hot pass. For hot pass, 1/8 rod, 140, 150 for your amps. I switched to cup size 10. It's a little bit easier, so you can fit right inside that bevel and have a nice good hot pass. Nothing fancy, just make sure everything is nice and clean. You can run a wire wheel after each pass. So once this is done, they're gonna do info shots or X-ray after hot pass. Okay, that's it. Hot pass is done. No more TIG welding for this joint. From now on, everything is stick. That's a welding procedure. Not really a big fan of stick, but you have to do what you gotta do. Okay, 2 purge lines here as well. I'm gonna check with a Purge monitor 100. Make sure there's no more oxygen left inside. Once the oxygen levels drop below 0.5, or you're pretty good to go. Okay, now I'm doing on my hot pass, on my root pass here. This is P91 SCAD 120 for 10-inch. The most important thing with P91 is gotta be really clean. Make sure your dams are good and the purge is good. Just got a little bit distracted with QC, a little bit show off here. Nothing fancy, guys. Okay, and root pass is done. Everything looks good and clean. It's easy with the horizontal pass. Nothing fancy. I was using a 1/8 rod for 532 gap. And now I gotta do hot pass. For hot pass, the same thing. Around 150, 160 amps on the horizontal side. As you can see, I'm holding on the top of the bevel and just stretching down that puddle. Make sure each pass is nice and clean. Always run a wire wheel after root pass. And that's it. Now it's ready for the QC. Now they're gonna do info shots or X-rays. And when that's done, then we're gonna continue on with stick. Just gonna speed up here for stick. After each full solid pass, they have to do MT and the PT. They want to make sure there's no any slags, no porosity. After that's good, that's done. Then they're gonna do X-ray again. So each pass is a procedure for a magnet. This is, as I said, night shift, day shift. So I got some indication from the QC to get rid of. They find some slag and porosity. So I'm just gonna take a grinder, clean everything with a wire wheel, with a grinding disc. And once you do that, this is a little tip: use a wire wheel, make sure everything is nice and clean, because after you run a wire wheel, you can see is there anything left. As you can see here, a couple spots, that's slag. And definitely they want to get rid of that because it's going to show on X-ray. I'm just going to fill to flash, clean again. When everything is nice and shiny, I'm just going to finish with the passes. So they went a little bit over. You see that line for the capping, so it's not going to be straight line for the cap. When you do stringer passes, you always don't stop on each spot. Make sure they're apart, so your stop starts. It's gonna be nicer and it's gonna be better. Okay, that's it. This is done. Capping is done with this one. As I said, this is like 5-6 days work, guys. Day shift, night shift. There's lots of testing, MT, PT, X-rays. There's like X-rays on those 8 X-rays on those 2 joints. So this is a post-weld heat treatment. Takes like 2 days to set up for that procedure, and then after that's done, then they're gonna do bake out. And same thing, the bake out procedure, and then you gotta call it off in sequences. You know, they gotta keep it. So it's like working on those Raptor SpaceX machines. How many wires here, and it's just crazy. It's mind-blowing, but it's technology. This is the science. You see how the bake out is actually hot. It's really hot, glowing. It's like over 1,000 degrees. That's it, guys. And the final result says this is 8 X-ray or 4 on each joint. That's done, and that's it. Hope you guys like it, enjoy it, and see you in the next one, guys. Take care.